Hello everyone. So in the last video I have discussed about the momentum integral method to find the boundary layer thickness. So I'll be using a small example to discuss that, which is a standard example basically, just to find a laminar flow rate flat plate and at a zero angle of attack only. So uh, so if you assume if you assume a velocity profile, it's a quadratic velocity profile like this. Anyways, it's not a bad profile. It's kind of good only. So if you assume a profile like this, so what are the boundary conditions? Boundary conditions are at x equal to 0, u should be 0. At at y equal to 0, u should be 0. At y equal to delta, this u is equal to free stream velocity. Technically, you can say 0.99 u, but anyways, you can write it as u directly. And then at y equal to delta, you can write it as dou u by dou y is 0. So, using these conditions, I can determine the velocity profile. Very good. After finding the velocity profile, uh, then I'll find the wall shear stress. Just tau W is 2 mu u by delta. And then per flow or flat plate, you know that the free stream velocity remains constant. That is, so if you consider this as a flat plate, the flow is like this, and flow will be u like this. Here only, like here the flow will be 0, but here and all the flow will be equal to capital U. This dou u by dou x is equal to 0. And then you know tau w, and then now this is 0, so you can write this as 0. So basically dou theta by dou x is tau w by rho u square. Now theta is a boundary layer thickness. So so the momentum thickness is given by this integral. So if you substitute the values in this integral, you will get a relation as 2 mu by rho 2 mu by rho delta u is same as 2 by 15 rho delta by dou x, or delta square by 2 is 15 mu x by rho u plus c. But at x equal to 0, that's when the boundary layer starts, which is delta is root 30 mu x by rho u. So delta x by is something like this, or delta by x is something like this. So from this you can find the skin friction coefficient. So this is how we proceed by using momentum integral method to find the approximate solution. Now to find the exact solution. The exact solution, though it is difficult to find, we can somehow find it and see that the exact solution is something like uh, delta by x is 5 by root rex. But here we got it as 5.48, so we can say that okay, it's very pretty close. So yeah, that's it regarding this laminar boundary layer, and also it's almost like an example for the momentum integral method. For the next video, I'll be discussing very briefly about turbulent boundary layer, and after that, this boundary layer heat transfer. Thank you.